Hi folks, welcome back to Physics with Captain Rod. I'm making a video here to help out with number 135 here in Chapter 4 in the Hibbler text here. So Chapter 4, number 135. So I've done kind of a sketch here of the problem, and you can see that problem in the textbook here. And the idea of the problem is this. The idea is that we're going to try to replace this force system with an equivalent force and moment vector or a couple moment to go with it. So basically now we're going to try to take this picture and we are going to replace it with this picture where we have a single force vector. Now I've just drawn an arbitrary force vector I just put positive basically x, y, and z directions, and a moment vector, a couple moment vector that goes around it. All right, so the idea here is to find these guys. Now the part in the question about where does this force vector break the xz plane. So there is some point here in the xz plane that has coordinates x and z where this force vector's line of action goes through. So unknowns in this problem are the x, the z, and the force vector here, and this couple moment vector. Now this vector here can be expressed a couple different ways. Method number one, it has an x component in the I direction, y component in the j direction, z component in the k direction. And we're going to be calculating a moment vector over here. So what I'm going to do here is I'm going to do a little notation here. I'm going to put a little, this symbol under these, where this is going to be representing this couple moment vector here, and then mx with this is this guy's x component, and so forth. All right, so the steps in this problem. Step one, first, get the resultant force vector over here on the picture on the left. That's the real easy step. The resultant force vector here is the vector sum of these three forces. I'm not going to do it in the picture. I'll let you do that. But suffice to say, this is going to come out to something like something I plus something j plus something k. And that's a pretty easy thing to get. Now remember, these two pictures have to be equivalent. So if I were to calculate the net moment about point O here, these two pictures have to be equivalent. So the next thing I would do is I'm going to come down to here. We're going to calculate the net moment about position O due to these three forces. And that can be done very easily in just standard two-dimensional land, I think. You've got this 200 newtons times this distance, positive I direction, and so forth. So go ahead and get this net moment vector. That's going to give the net moment produced by these three forces about point O. Now over here on the picture on the right, the idea is that this force and couple moment has to be equivalent to this force system here. If we think about the unknowns, we've got 1, 2, 3 plus the two unknown coordinates 4, 5. So that's kind of a kind of disheartening thing to think about. I'm going to go back now and talk about this this moment vector a little more. This moment vector is in the direction of the force vector here. You can think of this as a force with a moment vector around it, the couple moment part of it. And what we can do then is we can express this moment vector a slightly different way. It has some magnitude, I'm just going to call that capital M, and then times a direction. And the direction is the same as this force vector. So I'm going to call this, let's say, a force unit vector here. So take this force vector, divide its magnitude out, and you will have a unit vector in this direction. So this will now look like some sort of magnitude times, and it'll look like something I plus something j plus something k. All right, now when we look at this, and I kind of go back and kind of relook at our unknowns here, this will be an unknown, and then the two unknown locations. Now it's three unknowns, so this thing should be somewhat doable here. All right, so now how do we get those three unknowns? Well, we're going to get it from the fact that the moment about O has to be the same in both pictures. So in the picture on the left, what we have is this guy, mxi plus myj plus mzk equals, and remember, these should be known values. You're going to get these values just from calculating moments produced by these three forces about 0.0. On the right-hand side, we have a couple, two effects going on. There's a position vector that points from here to here equal to xi plus 0j plus zk. When we take that position vector and cross that with this force vector, we're going to get the moment produced by this force about this point. And here's what that's going to look like. So that's going to look like xi plus 0j plus zk, where again these are unknowns, x and z, crossed with our force vector, which we've calculated previously from this part right here. I'm just going to put crossed with f to save myself some writing here, but this is what you'd be putting in that spot. Again, calculated by the vector sum of these, plus the moment vector here, the couple moment applied here. Now again, there's two ways to write that, mxi plus myj plus mzk. That would be one way, but that's kind of like introducing three unknowns. If we express it this way, as some magnitude times, again, this unit vector would be a known quantity, something I plus something j plus something k. And again, where we're getting these values from here. And what we're going to get out of this now is three equations. By equating the x components, you'll have this plus, now you got to do the cross product here first, find its x component, right? And then plus this piece will give you one equation. Second equation, you'll take this equals, right? After you do this cross product, it will probably have a y component here. So you'll have plus that, and then plus this piece is going to give you a second equation. Same thing for the z components. You'll have this equals, again, after you do the cross product, you're going to have a z component piece plus this guy. And what you get is three equations, three unknowns. It's certainly not a short, easy problem, but I think that's mapped out reasonably well. That should get it done for you. Hope this helps. Have a great day.